In this video, we're going to take a look at something called density. So density, mathematically defined, is mass per volume. So mass divided by volume. So it doesn't really matter what unit of mass you have. You could have grams, you could have kilograms, you could have micrograms, that's an M, micrograms. So all these are different units of mass. If you have any of them divided by a unit of volume, meaning milliliters, you could have cubic centimeters, you could have kiloliters, etc. So there are a bunch of different units that you can have for mass and a bunch of different units that you can have for volume. But mathematically defined, density is mass per unit volume. So density is basically how much stuff is contained in a given space of material. So let's say, for example, let's say if I had a block of aluminum metal. So let's say aluminum, let's say it had a volume of 15 milliliters, and let's say it weighed 45 grams. Okay, so I know that the volume of my block of aluminum is 15 milliliters, and the mass of my aluminum is going to be 45. So before we go any further, let me clarify here. The unit of density that you're going to see most often is this one right here, grams per milliliter. So grams per milliliter is a unit of density. Kilograms per cubic centimeter, milligrams per kiloliter, all of those are units also, but this is going to be your most common one, grams per milliliter. This is typically going to be reserved for liquids. In contrasting, solids can also have density as well, so that's solids, that's an I. So, but typically for solids, you're going to have grams per cubic centimeter. So a cubic centimeter, let's say if I had a cube, so let's draw a cube here, and this cube was 1 centimeter by 1 centimeter by 1 centimeter. If I were to take a liquid and fill this cube up that is 1 centimeter by 1 centimeter by 1 centimeter, that would occupy a volume of 1 milliliter. So as far as conversions go, 1 milliliter is equal to 1 cubic centimeter. They are the same. You can use them interchangeably, but typically we're going to use grams per milliliter for liquids and grams per cubic centimeter for solids. So in this particular example, we've got milliliters for the volume of aluminum, but this is also, we could say, 15 cubic centimeters. They would be exactly the same. So for sake of keeping things similar, so instead of using the 15 milliliters, let's just use 15 cubic centimeters. So once again, the formula for density is equal to mass divided by volume. So the mass is 45 grams, so we'll say 45 grams, and the volume here we said is 15 cubic centimeters. So once we work this out, we take 45 divided by 15. That's going to give us 3 grams per cubic centimeter. Now if you were to actually look up the density of aluminum, it would not be 3 grams per cubic centimeter. I sort of made these numbers up, but it still works mathematically. But just know that this technically isn't the real density of aluminum if you were to look it up in a chemistry or physics textbook. But anyhow, in a nutshell, this is how you work out density problems. But let's say instead of me giving you the mass and volume, let's say I said the density of an object. Let's say the density here is going to be 4 grams per, this time let's do a liquid, 4 grams per milliliter. And let's say the volume that I'm going to give you is going to be, we'll say 5 milliliters, and I want you to tell me what the mass is. Well, in this particular example, you're still going to use the same formula. Density is equal to mass divided by volume, but you're going to plug these numbers into different spaces. So my density here is 4 grams per milliliter. My mass, I don't know, so I'm going to put M in up at the top. And then my volume, I'm going to put on the bottom, which is 5 milliliters. So if you remember from algebra class, in order to solve an equation when I have a variable in the top of a numerator for an equation, all I have to do is multiply each side by the denominator. So if I multiply this side by 5 and then I multiply this side by 5, the 5's here, well actually this is technically 5 milliliters and 5 milliliters here. So the 5 milliliters will cancel out. 5 times 4 is going to give me 20. The milliliters once again are going to cancel out because basically this is milliliters over 1, and so the milliliters will cancel out with the milliliters on the denominator here, and I'm just left with the unit of grams. So my unit here is 20 grams, and then the only thing I had left on the right hand side is my m. So this really means that mass is equal to 20 grams. So once again, you're still using this formula, density is equal to mass divided by volume, but depending upon the two quantities that you're given, you may have to manipulate the equation in order to find the third one. So let's do one more example. So here is a question that says a flask that weighs 345.8 grams is filled with 225 milliliters of CCl4. This is carbon tetrachloride. The weight of the flask and of the carbon tetrachloride is found to be 703.55 grams. From this information, calculate the density of the carbon tetrachloride. Alright, so once again, I'm going to use the formula that we used in the previous example. So I'm going to say density is equal to mass divided by volume. So let's go ahead and see if we can find out what these quantities are, mass and the volume. So the density we don't know, that's what we're looking for because it says calculate density, so I'll put a question mark there. The mass, so in order to find the mass of the CCl4 we have to go back up here and look. So a flask that weighs 345.8 grams. So if we draw a picture, so let's say we have this flask or beaker or whatever else, and just this flask by itself weighs 345.8 grams. So this particular flask is filled with 225 milliliters of CCl4. So the weight of the flask and the CCl4 is found to be 703.55. So let's draw this beaker again, but this time it's not empty, so let's kind of draw this liquid in it. So this blue is my CCl4. So we know that the beaker was 345, but now the beaker with the liquid in it is actually 703.55 grams. So in order to find how much the CCl weighs, just the blue, I would have to subtract the 703.55. I would subtract 345.8 from 703.55. So take the smaller number from the bigger number. And when you do that, so we'll say 703.55 minus 345.8. So when I actually subtract these numbers together, I'm going to get 357.75 grams. So this number is the mass of the blue liquid, the CCl4, that's in the flask. So let's go ahead and put this in for the mass. So we're going to put 357.75. Now the volume, if we go back up here into the problem, it says a flask that weighs 345.8 grams is filled with 225 milliliters of CCl4. This is going to be my volume. So I'm going to say 225 milliliters. So now I've got two of my quantities and I can solve for my density. So if density is equal to mass divided by volume, so we'll say density is equal to the mass, which was 357.75, and the unit on that was grams, so let's not forget the unit. So grams divided by the volume, which is 225 milliliters. So density, once I actually work this problem out, I'm going to get 1.59, and the units here, if you write your workout, it makes it almost where you can't get it wrong, the unit, so it's grams per milliliter. Like we said before, this is kind of consistent with what we said earlier because CCl4 in this case is a liquid, so it's filled with this particular liquid, and so we should use milliliters for the volume. So the end result here is 1.59 grams per milliliter, and this is your answer to the problem.